Welcome back to the FHIR in 5. I hope you're enjoying the series so far. We're up to the letter E today. And last time, if you followed my A to Z blog on FHIR Fun Facts, I covered extensions when I got to the letter X. I was starting to get a little creative with my choice of subjects in that last series. This time I thought I'd cover it with E. And I wanted to have a look at extensions from the perspective of trying to extend out primitive data types. It's a little different from a regular extension, and I just thought I'd cover it off so it's not confusing. I know when I first looked at what I'm about to show you in the extensions pace, I was a little confused as to why there was these underscore birth date fields in my JSON document. So hopefully this will cover off some of your questions around extending primitive data types. So first of all, I thought I'd show you what a regular extension looks like, if there is such a thing as a regular extension. So it's got a really simple structure. It's got a URL, which is the reference back to the information that relates to this particular extension. So how to work out what it actually means. And then it's got value X, and the value X just means that that's any data type of the type value. So there can be value string, value date time, value Boolean in this particular example case, but also value codable concepts, value coding. So all of the data types that are available in FHIR will have a corresponding value that you can choose from that's the most appropriate for your extension. So in our particular example here, we've got a patient resource, and apologies if you're used to seeing FHIR in XML. I tend to use JSON. So we can see a part of the FHIR patient resource there, and it's got an extension at the root level, so it's all about the patient, and it's got a URL, something called patient interpreter required. So I could follow that URL and find out more information about what this interpreter required extension is all about. So if I had an application that was appointment booking application, I might want to know whether they need an interpreter as well. So I may want to use this particular extension to gain access to that information. You can see it's a Boolean data type, and this particular patient does need an interpreter. So really simple extension. You can see that it's an array of extensions, so I can have multiple extensions at that root level, which is great. So now, moving into the main part of the topic, we're extending primitive data types. In the last video, we talked about primitive data types, or we talked about dates, times, date time fields. They're all primitive data types, and they're the building blocks of the data type within FHIR. Other data types include code. So if you look at the administrative gender field within the patient resource, it's a code data type, which is a primitive. And so every time we want to extend the primitive data type, we have to do what we've got on the left-hand side here with the birth date. So birth date is date field in FHIR, and it's a primitive. So we've got this underscore birth date, which contains information about our extension. So this is where the key difference of extending a primitive data type comes in. That underscore at the start, certainly from a JSON point of view, is indicating that we're wanting to extend or have some additional information around birth date that's not in the structure. So if we looked at the structure of a date, it won't allow us to include things like the ID, the extension. So we need a way of showing that within our FHIR resource. The extension piece itself looks exactly the same as what we saw in the previous example, where we're extending the patient for interpreter required. So the only difference really is that underscore at the front. So it is pretty straightforward if you think about it. The XML representation doesn't need that underscore. We can use the element inside inside the birth date element there. So we can include, or include the value, which is the birth date anyway. We include an ID for the birth date, and then inside that we can include the extension itself. Primitive data types can be repeated, so we can have arrays that are primitive data types. So in this example, I've just got a fictitious data type code or field code, which is an array of cities, and I'm putting in the nickname of the various city corresponding to the code. I should have put Brisneyland in for Brisbane, or Brisvegas, depending on what you think. And the thing you'll notice there is that the first one, so the Brisbane code, the B&E code, doesn't have the extension value for it. So we're just saying that the Sydney one has an extension. It relates to a nickname called the Harbour City. So if we want to have an extension for Brisbane, we could put that one in that first value where it's got currently null. On the right hand side, we've got the corresponding XML, if you're used to seeing that. The other thing is you can have multiple extensions, because that extension property is just an array. So we can have an extension which might be nicknames, it might be population, it could be anything that's defined by that extension. So hopefully through this simple video today, you can get an understanding of how we extend out primitive FHIR data types, and you'll know now when you see that underscore prefixing a primitive data type that we're adding some more information to that particular primitive in the form of the extension. If you do want to find out anything more about FHIR, reach out to me at Dedalus or any of the Dedalus team, and we can talk to you about our Digital Connect for Health platform, or DC4H, which enables interoperability solutions for challenges that you may have with your healthcare environment. There's a link coming up that will take you through to the website for more information.